Hi everyone, welcome to the third lecture of this ninth module where we are discussing on occupancy and motion sensors. We are discussing the course on microsensors and nanosensors. In our previous classes, we have discussed about various occupancy and motion sensors, including ultrasonic motion sensors and microwave motion sensors. Today, we are going to discuss triboelectric kind of occupancy sensors, which is a very popular kind of occupancy sensor, particularly when you need a sensor which to operate in passive mode. Okay, so as the name suggests, it is based on triboelectric effect. So let us quickly understand what is a triboelectric effect. Some of you might be aware of this, but the mass might be missing this concept. So let me first introduce this concept, and we will see that how this concept can be utilized to develop a occupancy sensor. Okay. In dry climates, it has been observed that walking across a carpet or on a, say, even on a tile in an isolated place, it can generate some kind of spark. Okay, and this spark is mostly generated because of friction between your leg and the carpet. Okay, this charge generation or the spark generation, this phenomena itself is known as triboelectric effect. Okay, so if you see this triboelectric effect, the process itself involves the separation of electric charges, which can be due to mechanical friction. So this is mostly triggered by the object's movement on a carpet or any other dielectric or charged surfaces. Okay, so this results from friction between a clothing fiber or air turbulence, atmospheric electricity, or other related effect. It can be any of these. Okay, so usually this involve a charge, mechanical charge redistribution in the carpet. Okay, or you can understand this as a between the person walking and the object or the carpet beneath. Okay, so this is mechanical charge distribution of in the dielectric material. Okay, we have also seen this kind of thing while we rub a glass rod with a silk strip. So when you rub a glass rod with a silk thread or a silk cloth, what it does is actually it strip off electron from the surface of the rod. Okay, so when you strip electron of this rod, it leaves some positive charge on the rod. Okay, please note that whenever we are talking this kind of charge redistribution, we should understand that electric charge is conserved in all these cases. Okay, so when I say electric charge is conserved, I mean to say that it is neither created nor destroyed, but it is just moving from the rod to the silk cloth or silk wire. Okay, so giving negative charge to any object in this two body problem, okay, means that taking electron from one object and placing them on the another object. Okay, so wherever you are placing it, you are making it electron rich, or you are making it negatively charged. Okay, so the object that loses some amount of electron is said to gain positive charge. So you have taken some electron from that object, means there is automatically some positive charge that is being generated on the object. Okay, so this is a basic triboelectric phenomena, but although if you see the two object, this carpet and the person's feet is making some kind of electrode system. Okay, however, this is different from the phenomena itself is different from capacitive sensor. Okay, so the triboelectric sensors are quite different from the capacitive sensors. In case of triboelectric sensors, no capacitance is being measured. Please note that what we are dealing is mostly with the electrical charge that is accumulated on the, say, if I consider it as a capacitor, so I am interested in not measuring the capacitance but the charge on the electrode. We will see with some example. Okay, so electric field is generated between the surrounding object when there is a plate. We have seen already the example, okay, and the electrode whenever at least one of them carries a electric charge. So when there is a electrode and there is some surrounding objects, it will form capacitance with each and everything. Okay, so there is capacitance associated with each and everything when the electrode is carries some electric charge, be it negative or be it positive. Okay, so all distributed capacitors between this plate and the objects in the surrounding, all these distributed capacitances forms between the electrode and the surrounding object are charged by static or slow varying electric field, which is resulted from the triboelectric effect. Okay, we'll see this with one example where we'll see that we can make a triboelectric detector using just one electrode. Fine. When there is no occupancy, the electric field in the electrode vicinity is either constant or it is changing relatively very slow, or you can say that it is almost constant. Okay, so if a charge carrier such as human or animal moves away, or a new charged object which is already carrying some charge enters the area with nearby the electrode, the static electrode field become disturbed. Okay, and this disturbance can give you an idea that the place is occupied or something is in motion. Okay, so when you have this kind of disturbances, this disturbance can lead to the redistribution of charge across the coupling capacitors, and this coupling capacitor is formed between all the objects which is in the vicinity of that particular plate. Okay, so this includes those formed between the input electrode and the surrounding ambient, as I have mentioned. Okay, now electric circuit can be designed to detect these varying charges at the input. Okay, or you can understand it that it can be configured to convert the induced variable charge which is coming on this plate, okay, into some electrical signal in the form of current or voltage, okay, which can be amplified and can be further processed. Okay, so this kind of sensor is known as triboelectric sensors. Okay, so let us understand the basic construction of a triboelectric motion sensor. Okay, so in this configuration, if you see, you have a electrode. Okay, this is a conductive electrode which is connected to a analog impedance converter. Okay, now this setup is made up with MOS transistor, okay, a bias resistor, input capacitor, and a gain stage and a window comparator. Okay, so this is a typical configuration of a triboelectric detector. Okay, now if you see this structure, this complete electrical circuit or this complete electronic circuit can be shielded. Okay, shielded from the charges in the vicinity. Okay, so for example, this person is in the vicinity of this circuit. Okay, so to avoid any kind of confusion or to minimize the parasitic capacitances, this complete circuit can be shielded from the vicinity, while this electrode, we call it a sensing electrode. Okay, this sensing electrode is exposed to the environment. Okay, now this forms a coupling capacitance with the nearby objects. Okay, I am calling it a CP. Okay, this is forming a coupling capacitance with the nearby objects because this is not shielded. Okay, the static electricity is shown by the presence of positive charges which is distributed across the person's body. Okay, so the person is carrying some static electricity which is shown by this positive charge distribution on the body. Okay, now the person become a source of an electric field as he carry this charge. Okay, now when he is carrying this positive charge, automatically when he comes near to this electrode, a negative charge is induced on this electrode. Okay, and immediately a electric field, say with intensity E, is established between this person and the electrode. Okay, now this electric field induces a charge of the opposite side that we have seen. Okay. Now let us consider two cases. One is in the case of a person is not moving, and in another case we will see that when what will happen when the person is in movement. Okay. Let's consider the first case when the person is at static place or he is not moving. Okay. In this case, the electric field intensity E remains constant. Okay, because the field lines associated is not changing. Okay. Now there is a field established and this capacitance is fully charged. Okay. Now this capacitance, this input capacitance will gradually discharge, and this discharge will be through this resistance R. Okay. We call it a bias resistor. Okay. Now to ensure the circuit responds to the relatively slow movement, this resistor R should be very high in say few gigaohm. Okay. It should be of the order of few gigaohm. Okay. Now let us consider that the person is moving. We have seen the first case when the person was at rest. Okay. Now he is moving, and because of that the intensity E, which is established between this person and the electrode, it starts varying. Okay. Now this varying electricity or this electric field generates a variable electric charge in the input capacitance C. So through this electrode, this capacitance starts charging. Okay. So this leads to the development of a variable voltage across the bias resistor. So as the voltage across this capacitance change, the voltage across this R also changes, and this is variable because this field is actually inducing, or this field is governing the voltage across this resistor indirectly. Okay. Now this voltage, the voltage across this resistor R is transmitted through this coupling capacitor to the gain stage. Okay. This is the gain stage. All right. And this is the coupling capacitor I am talking about. Okay. So this output is then sent to the comparator or the window comparator that we have seen. Okay. The comparator compares the signal with the two predefined thresholds. Okay. When the positive threshold is normally higher than the baseline static signal, while the negative threshold is lower than the baseline signal. All right. So during human movement, the signal at the comparator's input shifts upward or downward depending on the person's movement. This electric field is increasing or decreasing based on this person is moving in this direction or this direction. He can move at some angles also. It is perfectly fine. Okay. Now when this amplified signal is coming here, it is comparing this with two thresholds. Okay. If predefined threshold is crossed, the sensor will signal that the intruder has been found. Okay. So the window comparator usually produces square pulse output signals which can be used for further processing. Okay. So the element respond with a signal that is amplified and compared with the window threshold in a comparator. As soon as it crosses some threshold, it shows some value. Okay. Please note that unlike a capacitive motion detector, which is a active sensor, a triboelectric detector is a passive sensor. Okay. This is very important, particularly from the point of view of the difference between a capacitive and a triboelectric sensors. Okay. So this triboelectric sensor can work in a passive mode, or these are passive sensors, which is very, very important. Okay. So the triboelectric detectors neither generate or nor transmit any signal. So it become more challenging to detect these signals, and you should have very high quality gain stage and the comparator stages. Okay. Particularly the previous steps from the comparator, including the amplifier, is very crucial because the charges associated or the voltages associated are very, very small. Okay. But the good thing about this triboelectric detectors is that this is based on one electrode only, and rest of the part can be shielded and can be apart. So these electrodes can be hidden behind many non-metallic objects such as wood, brick and other things. Okay, so it give you that kind of liberty. Okay, so these all are basically sensors where you have to go very close to the electrode. We have seen the same in case of capacitive sensor, including the capacitive sensor where we have discussed about the occupancy of a chair or occupancy of the driver seat in a vehicle. Okay, so let us also see some of the devices where we can monitor these movement without bringing the person in the vicinity of a plate or this kind of mechanical arrangement. Okay, and we have to take help of optoelectronic devices there, and we call it optoelectronic motion sensors. Okay, so optoelectronic motion detectors are by far the most widely used type of intrusion sensors. Okay, they are very popular for intruder detector, particularly in the harsh conditions and at the places where human intervention is limited. Okay, where we cannot go and measure these things. Okay, so they operate using electromagnetic radiation within the optical spectrum, specifically at a wavelength of around 0.4 to 20 microns. Okay, so if you see this is a very wide range, 0.4 micron or 400 nanometer to 20 micron. This is a huge range which covers visible light, near IR and a portion of the far IR spectral regions. All right, so you are basically boasting to utilize this large range of electromagnetic spectra for this kind of intruder monitoring. Okay, so these detectors are primarily used to detect the movement of human as well as movement of animals. Okay, so they operate over distance of up to several hundred meters. So monitoring and data processing becomes very easy. Okay, so depending on the specific application, they may have either a narrow field of view or it may also have a wide field of view depending on what is your requirement. Okay, so based on the detection of light, there can be various operating principles. So based on detecting light, as I have mentioned, that there are various light regimes that I can use. I can use visible or IR rays. So they can be either reflected, or the body which I want to detect it can also be a source of light. Okay, so one way is if I emit a light and it is reflected or refracted from the object which is in motion. Okay, or other way of detection is the body itself is emanating some light. Okay, so we can detect that light also and comment on its motion pattern. Okay, so the IR is either reflected or emanated from surface of a moving object into the surrounding space. Okay, that is what depending on the operating principle, I can have these two kind of opportunities. Okay, so these radiations may be originated either by an external light, as I have mentioned. I can have external light for the monitoring. Okay, and it is reflected by the object, or as I have mentioned that it can also produce some it may also have some natural IR emission. Okay, so the first case where I am sending some light, it is getting reflected from the object and then I am detecting. So this kind of devices are referred as active detection, or this detection technique is known as active detection technique, while the second one where I am not sending the light but the object itself is emanating some kind of infrared radiation. Okay, this kind of detection is known as passive detection. Okay, so irrespective of the sensing element, following components are essential in this kind of optoelectronic motion sensor. Okay, you must have a focusing devices. It can be a lens or it can be a curved mirror depending on what kind of electromagnetic radiation you are using. Okay, so you need a focusing device. Okay, you need a light detecting element. okay, and you must have a threshold comparator, okay, and the source of light depends, you need or not, depending on you are using active mode of detection or you are using a passive mode of detection, okay. So an optoelectronic motion detector, please note that resembles very similar to a photographic camera, okay. So its focusing elements form an image of the field of view on the focal plane, something like this, okay. So this is the intruder, this is the say direction of motion of this person, okay, and this image is formed at the focal point or in the focal plane, okay. So it uses a light sensitive element in place of image sensor. That is the only difference between this camera and this kind of sensor, okay. So you are just using a light sensitive element, okay. You do not need a image sensor because I am not interested in the image formed of the object, okay. So it doesn't have a shutter like in camera. So the light sensitive element convert the focusing light into a electrical signal which is of our interest, okay. So as no real image processing is required in this kind of devices, such element can be considered as a single pixel optoelectronic detector. So you do not have to actually process the complete image, where you actually deal with multi-pixel kind of multi-element or multi-pixel kind of images, okay. So we know that these images are made up of multiple pixels. So here you do not need that. A simple electrical pulse is more than enough to suggest that if there is some change in the movement of the person or if there is no change, okay. So assuming the motion detection is mounted in a room, okay, a focusing lens create an image of the room on the focal plane, okay. So at that place the light sensitive element is located, something like this, okay. So you have a lens system and you are focusing that the light on this light sensitive element, okay. So if the room is unoccupied, the image remains static, there is no movement in the image, okay. Output signal from the element is steady and stable because there is no movement or there is no change in the electrical signal, okay. Now when an intruder enters the room and moves around little bit, their image on the focal plane starts moving, okay. Depending on how he is moving, he is at what angle to this lens system and how things are varying at the focal plane, okay. At certain point the intruder's body shift by an angle alpha, okay, and because of the shift their image overlaps with the light sensitive element. So please note that earlier this person was moving in this direction, for example, or in any direction, because of which his image was not forming here but it was forming somewhere here, okay. Now when he shifts his position by some angle and their image overlaps with the light sensitive object, which is light sensitive element, which is placed over here, okay, what will happen is it will be captured, okay. So please note that detection occurs only at moment when the object's image either align with the detector surface or moves away from it, okay. Either he is at stationary position when the object image is aligned with this, or it is in motion, okay. In these two cases only the intruder can be detected, and that is the demerit of this optoelectronic motion sensor, and we will see some techniques that how we can overcome these situations, okay. So if the image do not cross the detector, there is no detection. So for the detection, for the precise detection, this person while moving in this area, okay, has to cross this light sensitive element, okay. So if the image doesn't cross the detector, the image of this intruder doesn't cross this area, there will be no detection, even he is in movement, and if the movement is confined in this, or movement of the image is confined in this particular area, all right. So the intruder's body create an image with a photon flux which is different from that of static surrounding, okay. So this difference causes the light sensitive element to produce a deflecting voltage V, okay. Now, detection require the moving image to have a sufficient level of optical contrast with its surrounding. If there is no contrast, it will be very difficult to trace this intruder. Alright. So, figure shows the amplifier output signal V. This amplifier output signal V, when it is compared with the two threshold using a window comparator that includes both positive and negative threshold. Alright. So, the purpose of the comparator is very simple, as very similar to what we have seen in case of triboelectric sensors. Okay. So, the purpose of the comparator is to convert this analog signal V into two logic levels. 0 means no motion is detected and 1 means that a motion has been detected. Alright. So, before threshold comparison, the signal from the light sensitive element need to be amplified and conditioned, and that is why if you see, I have this kind of circuit element. So, the output from this light sensitive element is fed to a electrical amplifier. So, the output of this light sensitive element is in term of some voltage or current variation. Fine. Then only I can feed it to the amplifier. Alright. So, when the output is 0 means no motion is detected. When the output is 1, it means that motion has been detected. Okay. So, before the threshold comparison, signal from the light sensitive element need to be amplified and conditioned, as we have seen in the case of circuit diagram. Okay. So, in steady conditions, when there is no motion, the voltage V remains between the two threshold voltages. So, by this we can say that the place has been occupied, but the object is not in the motion. Okay. So, when a moving object's image overlaps with the light sensitive element, this voltage V deflects from its steady state position because the object is in motion, and at that particular time the comparator shows a output of logic 1. Okay. So, the logic 1, as we have already seen, means the object is in motion, okay, and in the field of view of the lens. Okay. So, that is how a basic optoelectronic motion sensor works, but we have seen that there are certain disadvantages with the construction of this optoelectronic motion sensor, and the disadvantage lies in the point that if the intruder is not, or the image of this intruder is not crossing this light sensitive element, okay, then how to comment on the occupancy of the area or on the movement of this intruder. Okay. So, that is the biggest demerit. So, you can say that if the person has, say for example, by somehow he has crossed the area, or my detector has already signaled that this person has crossed this area, fine. So, now he is, for example, here, okay, and if his movement is in this area, okay, so in that case the object's image say such kind of image is getting formed on the focal plane, and the object is moving in this kind of fashion, so that this image is not crossing the light sensitive element. Okay. In such a case, it is very hard to comment that if the intruder has left the room or he is inside the room. Okay. In such a case, we should have some solution, and the solution lies in the modification of the light sensitive element. Okay. So, in the next class we will see that what can be done at this front to get more accuracy and to comment exactly that where is the person, okay, and how to utilize this this particular field of view in a better way. Okay. So, we will meet with this discussion in our next lecture. Okay. Thank you.